Hello, good afternoon. Welcome to the Java 8.9 Beyond Ask the Experts panel. Kind of a small panel today. But
not very many experts.
Distinguished guests here. We have Brian Goetz, Java language and libraries architect. And Paul Sandoz, one of the engineers on the JDK team, does a lot of stuff with Jigsaw and streams. And I'm Stuart Marks. I'm also on the JDK core libraries team, and I do a bunch of miscellaneous stuff. I'm not even going to try to explain it. All right, so let's see. We have a few questions queued up that we started last night, and so maybe I'll just throw out a few questions. Oh, that's right. Sorry, I'm a little disorganized here. We are taking questions on Twitter.
So how many people here don't have a mobile device with them that's capable of Twitter? All right, so everybody who has your hand up, look to your left and right and find someone who doesn't have their hand up, and they can be your Twitter buddy. Yes, you can use my phone.
Okay, thank you very much. I will do the softball questions.
Okay, so we do have to talk about the safe harbor statement. This is all speculative and futures oriented. Do not make any commitments based on what we say here. All right, so we're taking questions on Twitter, and the hashtag for that is JavaQ. That was the same one that was listed in the abstract, so there are a few of those coming in already. I think what I'll do, though, is we have a few questions set up already, and how about the reification question? Yeah.
Is that a question?
Yeah, not yet. I'll phrase it. I'll rephrase it in the form of a question. Okay, so Brian, in your talk yesterday, you talked a lot about some interesting things, including specialization and dealing with generics and so forth. But that seems to have pushed this talk of reification off the radar. But we talked about reification for quite a long time. So what happened to reification?
So let's do a little trick the audience poll here. How many people here think they would like to have reified generics? How many people would have raised your hands if I hadn't told you it was a trick question? So obviously this is a popular question. And you know, I've had this conversation with hundreds of people who come up to me on the street or in the men's room or whatever and say, you know, when are you going to reify generics in Java? And what I always ask them is, well, why do you want reified generics? What's so bad about the status quo that this is such a big deal? And about 90 to 95% of the time, the questioner doesn't know why. Usually the answer is some variant of, well, because erasure sucks. And if you try to dig into this about, well, why does erasure suck? It almost always comes down to an aesthetic concern of, well, it seems like you have some valuable information that you would like to be able to retrieve later, and you're throwing it away, and that seems inelegant. But when you kind of, and there are some other serious pain points that we go through for the lack of reification. The most significant is it's much harder to build libraries that do serialization and deserialization type stuff, like serializing objects to XML and back and things like that. But the reality is reification is something that sounds like a really good idea, but when you start to look at the costs, it doesn't necessarily seem like as good an idea. So if I phrase the question here, how many people think it would be a good idea for the VM to have to do generic subtyping checks on every array store? Yeah, no one ever agrees with that one, right? But that's the reality of, if you follow reification to its logical conclusion, that means you're pushing the type system into the VM. The VM is responsible for enforcing these type decisions, which means the VM has to reason about wildcards. And asking the VM to reason about wildcards is putting a lot of additional work on the VM. The compiler guys for the Scala compiler or the JRuby compiler, this would give them absolute fits to have to deal with the Java generic type system baked into the VM. So very often, you know, people will backpedal. Well, I didn't mean that by reification. I meant something else. There's many possible something else that reification could be, each of which is weaker than what I just described. Like, well, could I have the type information available at runtime, but not necessarily checked at runtime? And that's easier to do, but it also doesn't bring all the benefits that people thought they were going to get for reification. So it's one of those things that seems like a very attractive idea, but when you start to look at what the real benefits are and what the real costs are, erasure starts to look like a really practical compromise, and especially from the perspective of the JVM is used not just by the Java compiler, but by the Scala compiler and the JRuby compiler, etc. So instead, what we our current thinking is, let's look at the pain points that people actually experience as a result of erasure. One of them is it's much harder to write good serialization, deserialization frameworks. Well, what would we need to solve that? What we need is better type literals. Because the thing that's painful about that is being able to pass in type information that this thing is a list of map from string to string. If we could describe that, then you could write these APIs without needing full reification. Similarly, you can't have generic arrays. Well, if arrays weren't mutable, and most of the time when you want a generic array, it's because you want a list of functions and you're not going to be mutating them, this wouldn't be a problem. And the last big pain point is I can't have a list of int or an array list of int, and we can address that through specialization. So we think that it's possible to get most of the benefits that reification would give you without imposing Java's wildcard generic type system on the VM, which is both painful for the VM and super painful for non-Java languages that want to have generic type systems that run on the VM. So how many people think reification is a good idea? See, it works. Jedi mind trick works all the time. This is not the feature you're looking for.
All right, thanks, Brian. Okay, so I'm going to throw one to Paul here. So Paul, you had a talk about Jigsaw yesterday,
yep,
and some very interesting technologies there. But what is likely the impact of Jigsaw on average Java developers?
Hopefully nothing initially. It should be backwards compatible with what we already have today. I think the impact will be if you want to move to a modular world from the class path world, you're going to have to turn your applications into modules essentially and have module descriptions on them. And if you're dealing with a big code base, that code base might not be easy to split apart into modules. And we've learned that lesson with the JDK, which took an awful long time to get to the position where we are in now to actually make it modular. It took years and years of work to tease apart logging from beans. We still can't tease apart beans from desktop just yet, and stuff like this. So it's got to that point. But if you're already in a modular world today, the move to that, we're going to try and make it as easy as possible by integrating with existing tools like Maven and Gradle where we can with help from the community. And we hope over time, and a long time, that people will be able to transition to a more modular world and get rid of the class path hell that we're in today. When I asked the question in the Jigsaw session, who experienced class path hell, quite a lot of people raise their hand. In fact, let's ask again, who's experienced class path hell here like this? Who likes class path hell? Nobody. Exactly. So Jigsaw is, one of the goal is to aim to not just modularize the platform itself, but to try and improve this situation that you have when you're dealing with lots and lots of jars. This is not something for smaller projects in a sense, but if you've got lots of jars on your class path, there's a better way to arrange this information and to deal with errors. So I hope that would have the impact will be, if you don't want to use it, you don't have to, but going forward, it should improve your life from class path hell.
All right, thanks, Paul. All right, I will go to Twitter and take one of the questions from there. Are you planning to skip version 9 and go straight to 10? So I'm not only the moderator, I'm a panelist too, so I think I'll take that one. And the answer is no. There are plans forming for Java SE9, and there is this is an open process, and actually the implementation is mostly in OpenJDK, and OpenJDK has the JEP process, the JDK enhancement proposal. And so if you go look on the OpenJDK website, if you go find, there's a link to the list of JEPs, and if you go look at that, there is a slowly growing set of JEPs that have been approved for inclusion into JDK 9. And now all the stuff that Brian talked about yesterday, this whole business about value types and Yeah, that's way future, post 9. So there's long-term stuff going on. It's very interesting, and everybody loves to hear Brian talk about it, and it's great stuff, no question about that. But there's lots of activity going on with JDK 9, and so when I think there was a little bit of disappointment initially that a few JEPs were announced, and there's kind of this is kind of okay, but nothing really interesting. Is this going to be all there is in JDK 9? Answer: no. And so I think since the initial round of JEPs were targeted towards 9, there have been 3 or 4 additional blocks of JEPs, and I suspect there will be more. In fact, one of my action items is to file some JEPs that are targeted for 9. So there's more stuff going into 9. It's not the earth-shattering, really cool pie-in-the-sky stuff like value types, but there's definitely stuff going on in 9.
And just to follow up on that, we've seen a number of articles and blog posts, where they look at the list of JEPs and they say, boy, JDK 9 doesn't look very impressive. There's only like these set of JEPs. And that's because we're sort of updating our process a little bit. So as you can imagine, we used to have a very waterfall process for planning the JDK, and it worked about as well as you'd expect any big upfront waterfall design to work. And so we're trying to move to I don't want to say agile because that's promising too much, but we're trying to move to a more flexible model where instead of doing a big design up front and then when reality hits we do a bunch of this thing has to get moved to the next version, we're instead trying only to schedule things for the next release when we're confident that we're actually going to hit that. And so there's development work that goes on to prototype and analyze things, and then once we're confident we understand the feature, we can implement it, we have the resources, we have the testing testing resources available, then we will propose to target it to JDK 9. So the list of things that may be targeted for 9 at any given time is mostly the things that we are really confident we're going to hit on, and that list is likely to increase over time rather than having a big list at the beginning and having that list reduce over time.
Okay, thank you. All right, so here's another question that I'm sure we get asked a lot. It's about parallelism. So in Java 8, parallel streams were introduced, and it's really convenient to do that, and we all love parallelism, and we all have multi-core machines now. So should I just use parallel streams all the time instead of sequential streams?
No.
Paul's shaking his head. Go ahead, Paul.
No. I'll be talking tomorrow. I'm not sure if a lot of you will be around tomorrow, but on this topic, on whether you should go parallel or not, and it has a cost associated with it. And if you just naturally assume that parallelism by waving this magic wand will utilize all your resources efficiently, it's not going to work. There are a number of factors that you need, including how many pieces of information you're operating on, what's the size of your collection, what type of collection it is, and so forth like this. And it takes time to ramp up all these threads to crunch on things and to produce a result, and there's a fixed cost to that, and you have to have enough information and enough work to overcome that fixed cost. So if you've got a really small collection, you shouldn't be putting parallel stream on it. We can't do magic at the moment to pull that out. I don't think we ever will. So you have to use it with care.
And like all performance optimizations, parallelism is strictly a performance optimization. It's supposed to get you the same answer, hopefully faster.
Yep.
But it's not, it doesn't have any fundamentally different semantics as the same computation sequentially. And so like all optimizations, you should use them when you know you need them. You should have performance targets, you should have performance measurement, and there's no point optimizing code that's not the bottleneck in your program. And parallelism introduces non-determinism, which is one of the trade-offs you make for hopefully getting the answer faster, but introducing non-determinism into your program when you're not going to get a tangible benefit, like it's going to run faster on these benchmarks, is not a good trade. And so it's really tempting to go and say dot parallel everywhere because parallelism is better. But the reality is you should probably start out the opposite. Start out doing things sequentially, and then chances are your performance may be fine, which is great. You're done. You can move on to other things. And if it's not, do all the usual things you do, measure profile, figure out where your bottlenecks are, figure out which queries are the source of parallel issues, and then try them in parallel and see if it gets faster. There's a lot of things you can do that a lot of innocent mistakes you can make that will undermine the benefit you would get from parallelism. And so, you really need to focus your efforts where parallelism is really going to make a difference in your program. The big benefit of having streams be able to execute either sequentially or parallel is not so much that we think everything should be parallel, but we wanted to make it so that if you want to switch from sequential to parallel, you don't have to go rewrite all your code and do it with fork join. You can just make a very local switch, and because your sequential code and your parallel code are so similar, the degree of additional testing you then need when switching one calculation from sequential to parallel is relatively small. So it's more about writing the same code in both models rather than encouraging people to go parallel everywhere.
Easy to do, not always the right thing to do.
Yeah,
I think that's a
exactly.
mantra. Yeah.
So you mentioned something in there when you say, maybe you have a performance problem. So go do all the usual things like profiling and measuring. And so I'd throw in measure, don't guess. And measuring is very important, and it's also very subtle. It's very, very easy to measure something incorrectly, especially when you're talking about JVM performance, because the JIT compiler is very smart and will, if you throw together a little benchmark that does, system.currentime millis and then does some work, and then you call system.currentime millis again and take the difference, right? How hard could that be? Well, it's most likely going to be wrong. There are many, many things that JIT does to spoil benchmarks like that. So measuring is very important, and it's also important to measure correctly. And so one of the things that we've been using a lot is a benchmark framework that Alexei Shipilev developed. He's another Oracle engineer, one of our performance engineers. It's called JMH. It's an open JDK project, and basically it goes to great lengths to do very precise measurements and statistics, and also avoiding the usual JVM benchmarking pitfalls. So I strongly recommend you go look at that if you need to measure the performance of something. I think we all use it, and it's a really very powerful tool.
How many people use it today? So there's still some users of it. It's really good.
Yeah, so just go to the OpenJDK website, and there's a link to JMH on there.
And at this point, when people send us, I wrote this benchmark, and it shows that this is like slower than that. If they haven't written it in JMH, we don't even look, because
it's almost certainly wrong.
Of the last 1,000 times we've evaluated one of these benchmarks, like 990 of them, they were making common benchmarking errors that would have been addressed by JMH.
Okay, go back to Twitter and take a question from there. Question is, at what point will having Java versions be backwards compatible become too big a burden? So I'll throw in some comments on that. And I don't think backwards compatibility is a burden. It is a constraint. And I think that is one of the things that makes Java so valuable, is dealing with backwards compatibility. I think there are some changes that we could make to the way the Java platform evolves, and that's one of the things I'm involved in. I don't think that backwards compatibility is something that it's like you can never change anything, because the ultimate backwards compatibility constraint means that you will never be able to change anything. I think what we need to be doing is being a little more aggressive about evolving things. And so what that means is it almost never means taking out old broken stuff, because chances are that somebody out there uses the old obsolete stuff and will totally be broken if it's gone. But instead, what I'd like to see happen is something more like, okay, the old lousy stuff is going to have to stay around for compatibility purposes, but then we bring in new layers of things and come up with better ways of directing people away from the old things and towards the new things, maybe changes to JavaDoc, changes to compiler warnings, telling people about that.
IDE plugins.
Yeah, IDE plugins, yeah, that's a good point there. So one of the problems is, for instance, I think, actually you might be able to change this in IDEs, but if you request code completion, you get all the deprecated methods, and they might be in strike through, but optionally. But things like not providing, not putting all of the old obsolescent stuff in your face, and instead, coming up with things that direct developers towards the new stuff. And so I think what we need is a better pipeline of new stuff coming in, and the old stuff either maybe, if necessary, being taken out. I think the usual whipping boy for that is Corba.
Serialization.
No, see, well, the problem,
we can't modularize serialization.
we can't
It's stuck.
Yeah, no, I mean, Corba is something, let's see, you asked about Corba in your Jigsaw.
There was tumbleweeds going by.
Yeah, it's like okay, let's try again. Who uses Corba here? I see, one
brave
guy.
person put a hand up over there.
I'm sorry to hear that, sir.
Who's too afraid to admit they use Corba?
Actually, people are less afraid to admit they're still using JDK 1.1. Actually, so for big things like Corba, I think the intent is, I mean, again, speculating here, but turn that into a module, make the module be optional, and then over time, if you need to use Corba, then you have to download this additional module and plug it in instead of it being included in every single JDK by default.
Yeah, that has a maintenance cost for us too. Yeah. So that we have to focus our time in certain areas, and we have to focus on Corba as well as other stuff. And over time, if we can focus less on Corba and less on the issues, pull it off the class path, we can focus on more better stuff going forward in the JDK.
Yeah. So there's definitely a cost to maintaining all the old stuff, and I think so. So my thinking on this is to be more aggressive about pushing stuff off to the side and leaving things behind in the platform. But there is never going to be a day where we say, okay, when we go from Java N to N+1, it's incompatible, and we're going to fix everything. You can probably think of other projects that have done that and are having a terrible time with it. So we're not going to do that.
Yeah, and I think Stuart's absolutely right when you say, it's a constraint. It's a constraint that we have to engineer under. And there's something kind of subtle about compatibility, right? It's very frustrating to be told, well, we would like to fix that, but we can't because it would be incompatible. And that kind of sucks. And after you hear that a few thousand times, you start to think, well, what is your guys' obsession with compatibility? Why don't you just have the guts to just break some people's code, right? And of course, really what they mean is break somebody else's code, not break you would never break my code, right? And but there's a reason why this seems like such an easy thing to suggest. And the reason is, well, we've never done it before. And so you've never seen the fallout that would have happened if we threw all our customers under the bus. It's not pretty. But because you've never seen that carnage, it's easy to say, well, just go ahead and break something. The reality is Java is the world's most popular programming platform because we haven't thrown you under the bus. Okay, we take great care to not break the code that you wrote 15 years ago and don't want to touch. And that's why Java is so popular. And so we're very mindful of the fact that, yes, it would be lovely to get rid of some crappy old features. It would be lovely to fix some mistakes. And we've made plenty of mistakes in the past. And it would be lovely to fix them all. But unfortunately, that has a cost. And that undermines people's confidence in being able to continue to use Java, deploy on Java for the next 20 years. And so this ecosystem wouldn't exist and wouldn't be this vibrant if we hadn't made this commitment to compatibility. So when we talk about let's have the guts to make a compatible change, you have to weigh both the benefits and the cost. And the cost is, it's not necessarily one that's as obvious as the benefits, but it's big. And it's one that we care about a lot.
A lot of budget spent on working out how to keep that compatible.
Yeah.
Yep. Like upgrading collections in past 9 into sticking in value types and reification. A lot of that budget's looking into the compatibility.
Yeah.
As well. It's a tricky thing.
Mm-hmm. And that's, when Stuart says it's a constraint, a good example of that is default methods, right? A lot of people, when they saw us going in the direction of default methods, said, well, why, you're being silly. Why not just do traits? Why not just do traits, right? And we actually spent, quite a lot of effort looking into what would it mean to just do traits. And not surprisingly, it's harder than it looks. And all of the pain comes from how do I migrate something that is an interface today to be a trait tomorrow in a compatible way such that existing class files that reference it still link. And that turned out to be a pretty big project since our requirement was we needed a way to evolve interfaces. Default methods were a simpler potentially less powerful, but also considerably simpler, way to get there. And so, when Stuart calls it a constraint, one aspect of that is when we look at the 5 or 6 or 10 or 20 choices that we have in front of us for getting to a goal, we may prefer those that lean more heavily on compatibility with not only with existing code, but with users' existing understanding of the language. People have invested a great deal in understanding Java, and we don't want to invalidate that understanding. We don't want to say, oh, well, if you want to continue to program in Java, you have to throw out everything you know and go take some new training classes and buy these 30 books. That's as bad as breaking your code, right? And so it leads us to prefer solutions that are more consistent with what we've done in the past. And sometimes it just means looking harder for them.
Okay, all right. Let's see, another question from Twitter. Will Java get a REPL, meaning Readeval print loop?
Yes.
Yes.
And there's a JEP for that, targeted at Java 9.
Well, it's actually an OpenJDK project, right?
It's an OpenJDK project, Project Kula. There's a Mercurial repository. There have been half a dozen pushes in the last few weeks into that repository. There's a mailing list. It's still very raw, but it's actively in progress.
So how does that work, right? So if you have a Readeval print loop, so it's one of those things like Python or Lisp or something, you just type expressions at it. Mm-hmm. But how would that work for Java? I mean, what does that mean? Is the first thing I have to type public class main open brace public static void, right? I mean, that's not much of a that's not really much of a Readeval print loop, is it?
No, and that's not what it does, right? So you have there's a couple things that you can type in a REPL. One of them is a Java expression, so anything that matches the expression production in the JLS grammar is considered an expression. Additionally, you can throw declarations at it, variable declarations, method declarations, class declarations. And again, these are all, relative to the to the language grammar, and it builds up a model. It does, of what you've entered so far. And this is a little bit different from what the compiler does because it's an interactive tool, and therefore we want it to work a little bit differently. So, for example, within a class, if you have public void foo, and then you say public void foo again within the same method, the compiler will bark at you saying you can't have 2 foo methods. But in an interactive context, what you'd like is the second time you enter public void foo, it throws away the first one and replaces it with the second one. So it's a little bit different from how the compiler works, but it kind of works as you'd expect. You can give it variable declarations, method declarations, classes, expressions, statements, and it will preserve the values of expressions and assignments that you've made, through the course of the conversation, and it'll print out the type and the value of the expression that you've entered. Pretty nice.
Cool. All right. Jigsaw question here. Will you set up a Jigsaw Central module to repository like Maven Central? Is there going to be a Jigsaw Central?
This is not a technical question.
Where's that safe harbor slide?
Yeah. Well, or it's like, let's reinterpret a little bit. Is that a good idea? Would that be a nice thing to have? How do you envision
I'm kind
that?
of open to thinking about these the modular bits of the platform. Where would they reside, and how would you get access to them? So one place you could put them on is Maven Central, and I did some experiments, and the jigsaw graph I showed, it actually translates one-to-one with Maven, very easy to resolve via Maven. So why? We could put them on Maven Central. If we don't, I'm scared someone else will do it instead. So we got to think about this carefully and what we do here, because Jigsaw is sort of changing the way the JDK is going to be distributed, and we've got to think about that carefully. And people are going to distribute the JDK in Docker images and stuff like that. Set it Docker. We're buzzword compatible again.
Yeah. Oh yeah.
But that's the reality of where things are heading, and I think we've got to think about that seriously and take it very seriously what we do there. So we just got to work it out. Technically, I don't think it's an issue. I think there are other. It's a legal issue, a political thing, perhaps, stuff like that. So
it's pretty unlikely that we would operate a repository for other people to push code to, because that's just not how Oracle works. But certainly we need a distribution mechanism for distributing the Java SE bits, the Java EE bits, and
the modules you might compose your own out of.
Exactly.
Yes. So if, for example, in Maven, you might want to say, I depend on Java Desktop or something like that. You can't express that at the moment. But if you wanted to express it in your project, it would have to exist in a Maven-y-like thing somewhere out there. And the obvious one would be Maven Central. So we have to think about it carefully.
Yeah.
Okay, so here's another Twitter question that's pretty close to our hearts. Are collection literals still being considered? So why don't you take the language angle on that first?
So collection literals has come around a few times. It was one of the things that just barely didn't make the cut when we did Project Coin in Java 7. It came around again in 8 in the context of Lambda, and we kind of decided it was a little bit out of scope for that. And it was something that we really wanted to get around to in 9. So at the beginning of the 9 process, we took a good look at this and discovered something that should not be surprising at all, and that is it's bigger than it looks. So, and this is the problem, right? It sounds like such a gimme of a feature. It sounds like, oh, that's a couple weeks engineering work and you're done. And so we spent way more than a couple weeks of effort looking into this. And we kind of discovered that there are two, there's a whole spectrum of how you could implement collection literals in the language, and there are two kind of stable points, both of which suck. So stable point number 1 was the one that was proposed during Project Coin, which is, let's have a literal syntax for set, list, map, and nothing else ever. Not only does this mean we have to add a whole lot of new syntactic forms to the language for a relatively limited payback, it seems kind of mean. And it also cuts off our expansion path for the future about what happens when we upgrade the collections, or what about Guava collections, or what about JSON, or what have you. And so while that was a gimme, it was a pretty weak feature, and the return on complexity for that feature seemed very low because it was adding a lot of new cases to the language and new syntactic forms for a relatively small payback of just being able to express sets, lists, and maps. So then we looked kind of at the, elsewhere in the design space, and we looked at quite a few different options and how different languages do this. And the other stable point in the design space is some kind of metadata-driven facility where you can say, I am something that is constructible via a literal, and here are the method calls to make to add something to my builder, and et cetera. And what we would have to do to adorn set, list, map, and potentially other classes like, JSON or XML to support that. And it was, even with a relatively small set of examples from which we were extrapolating, it was surprising at how the complexity of this ballooned out of control, and how complicated such a facility needed to be, and how messy it turned out to be, because it was a fairly poor match for the mechanisms we had in the language for expressing these things. So that seemed, pretty unpleasant as well. And so the observation we made is, this actually doesn't need to be a language feature. This could easily be a library feature. So, except for one thing. I'll let Stuart go, and then I'll come back to the one thing. So go ahead.
Yeah, I'm interested in what this one thing is. So, okay. So, and this actually ties back to the JDK 9 question that came in earlier, which is, so I have written and sent around for review a draft JEP to introduce a library replacement for collection literals. And so, this should be pretty simple. Inevitably, I posted on a Core Libs Dev, and there's a whole pile of discussion about it. Inevitably,
it would be really nice if you also
there's,
did.
Should do this and this and this. And so one of the challenges I have is to figure out, the right place in the design space to cut off the endless feature creep and, move that JEP forward and actually start implementing it. So it's not there yet, but this is something that seems to be, in our minds in scope for JDK 9. And the API should be pretty simple. Just add some static, add a static method to, say, the set interface, set.of a, b, c, and you have a 3-element set, and so that's not quite as nice as the nicest collection literal syntax that you might add to the language, but that's pretty darn nice.
It's only like 3 characters more than like curly brace a, b, c.
Okay, so what was your vote for one thing?
So you can handle list and set fairly easily with factory methods. List.of a, b, c, really not that bad. Like I said, only a few characters more. I guess 4 characters more in the case of list and 3 for set. The hard part is map, right? Mm-hmm. Because we don't have a way of expressing a mapping or a pair. But if we had a way of expressing a mapping or a pair, then a map literal would be map of pair, 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 pair. So, what's on the horizon past Java 9? Well, value types. What does value types give us? Value types gives us an easy way to express tuples. And so if we look at the evolutionary direction for the language, the answer to why we can't do this as a library in 9 is coming relatively soon after 9, in some small integral number of Java versions. And so designing a language feature that will be obsoleted by language features that are right over the horizon seems like adding complexity for limited return, because the benefit only accrues in the next 2 years as opposed to the next million years. And so having spent a fair amount of time looking at the design space for this, we actually concluded, well, it is a couple of weeks' work to do the library version. I mean, you'd think it would be 5 minutes' work, but it really is a couple of weeks. Doing a good language, version of this feature is a substantially bigger project, surprisingly so. And so when you look at it and say, well, should we spend, 6 or 10, engineer months on this, or should we invest that in value types or specialized generics or, better parallel support for IO-centric operations, in streams, it seems like the payback is better elsewhere. And so we, after having done the analysis, we said, let's do some libraries. And then after we have value types, we'll do some more libraries, and that'll be the end of it.
I think that that point you raised, there's this tension between what we do now and what we see in the future and what we can do better, and we have to balance those two out. We have the same thing with the collection literals, same thing with the streams API, why we didn't add a zip method which people want and so forth like this. There's other things we haven't added yet because we can do so much better later on. If we add them now, they'll stick out like sore thumbs.
And then 15 years from now, we'll be talking about why haven't we deprecated this yet?
Yeah.
Right. So just to clarify in this zip stuff, you mean why is there no way to zip two streams? And I think you're alluding to the idea that, well, so the obvious result of that would be a pair, and so that brings in Brian's discussion, which is the only way to represent a pair today is with a conventional object and so forth. But in the future, a pair would be a tuple, which would be a value type and be much more inexpensive and much nicer API as well. And so in fact, by doing something like we might do something with zip. It's hard to say, but doing sort of the obvious thing now with zip will definitely get in the way in the future, which is, okay, now we have to overload some stuff. When do you want it to return an actual tuple instead of one of these cheapo generic pair classes that we came up with?
And we actually, Zip is a good example because people like to throw rocks at the API and say, why didn't you idiots think to add a zip method? Well, actually we had one. And we were reluctant to put it in, but we because of all the reasons Paul just described. But we said, all right, let's give it a try. We put while we were doing the development of JSR 335, we put a zip method in, and we got this resounding chorus of, well, this wasn't the zip method I wanted. And so all the people who were saying, give us zip, was like, we don't think you're going to like it. No, we really want it.
This is not the zip method you were looking for.
This was not the zip they were looking for. And so, that gave us the confidence to say, all right, we didn't think it was going to work, but we tried it. It actually didn't work. We can imagine a future in which it can work much better. So that's, we're going to wait for that future to emerge. And again, that's got to be frustrating for everybody to hear, right? That like, you have code to write tomorrow. You can't wait, 2 more years or 4 more years, or until your, manager lets you start writing in Java 10, that could be forever, right? So we understand that that's frustrating, but it's because we have to balance the short-term benefit of the ecosystem against the long-term. We're constantly having to make decisions like this, and whichever way you decide, you're going to upset somebody, right? There's no winning move here. There's just in which way are you more willing to lose?
Okay, so here's one going back to Paul and Jigsaw. So when Jigsaw comes along, are jar files going to go away?
No.
Okay, great. Now let's
Next question.
There was some confusion in some of the JEPs that were released around Jigsaw, and there was confusion on Twitter, which is extremely easy to get confused on Twitter, about jar files going away. They're not going away. They're going to be here forever. As long as Java's here, jar files are going to be here forever. And in the Jigsaw world, you can convert your jars into modular jars by putting a module description in them. So they're not going away. They're a fine format for portable distribution. and not so good format for execution of code, but they work. They're staying here.
Okay. All right. So here's a JVM question that came in. When is the JVM going to support Tailcall elimination?
Yeah, this is a question that we've been dodging for quite a long time. So there's an interesting story about this, which is hopefully by the end of the story you'll have forgotten what the question was. For a long time, there was a sort of surprising reason why we couldn't do tail calls. So people would ask for tail calls, and we couldn't really tell them the answer because the answer was secret of why we couldn't do it. And it has to do with how many people here have ever know what the caller-sensitive annotation that was introduced in 8 does? Has anybody seen this one? So nobody. Okay. So it turns out, buried deep in the JDK, to the embarrassment of some of us, there were some security-sensitive methods that relied on counting the number of stack frames inside the JDK to find the calling context, right? So you have some methods like, class loading and things and reflection and such that have to know who's asking, because they have to be able to say, what set of access permissions am I supposed to use? And they were called not directly by client code, but by JDK code that was called by client code. And so in order to, in order to figure out who was calling, they had to do a stack walk. And some of these stack walk computations were very brittle. So anything that interfered with the number of call frames between, a caller and an indirect callee would have been a security problem. And so for that reason alone, we were unable to consider tail calls at all until all of those problems were fixed. Now, thankfully, we did a huge sweep through the JDK in the 8th process, and we got rid of all of these brittle stack frame counting codes, which removed a huge impediment to being able to do tail calls. There's a prototype for tail calls in the MLVM repository. It's not terribly difficult. We know it's not terribly difficult. It's one of many, many worthy projects that are kind of on the list waiting to come to the top of the priority list. So the answer is hopefully someday. Doesn't seem to be happening in 9. Keep bugging us. Maybe we'll get so tired of being asked that we'll just do it to shut you up.
Yeah, I think what it takes is sort of the next feature to really bubble it up to the top of a priority list. And there might be some coming which sort of push it up to the top a little bit higher, which force it up there, I think. Doesn't Guy Steele every year at JVMLS, he does. I want my tail calls, and
yes,
did it at the original one.
Yeah.
keeps asking patiently.
He's very patient, but insistent.
Yes.
Yeah, this is. I mean, there's a bit of history with the personnel here. I think all of us worked for Sun. At least a lot of people on the Java team worked for Sun, including Guy Steele worked for Sun for many years and wrote the original Java language specification. And of course, if you know Guy Steele, he's an old Lisper, right? So he's really all on top of this. And so he makes impassioned pleas for this from time to time. And the JVM architect, John Rose, is also an old Lisper. And so he is well aware.
Total coincidence.
Yeah. He's well aware of the importance of tail call elimination. And so it's definitely something that gets talked about recurringly. It's something
recursively, maybe.
But there are all these incidental issues with it and the priorities and stuff. So it's on the list somewhere.
And we're one step closer, a big step closer.
Yes, exactly.
We've cleared a big impediment.
All right. What was the next? Moderator fumble here. I queued one up and then I forgot what it was. Talk amongst yourselves.
Has your Twitter client crashed?
No. I had something in mind and I forgot what it was.
His brain is rebooting.
Yeah. How about a generics question?
Okay.
Is there anything? Generics have been around for a while, and they're really complicated. And in my previous talk, if some of you saw it, gave you a kind of an exhortation for everybody to learn generics. But the fact is, generics are pretty hard. Personally, I had one of the hardest features for me to learn about Java. So, is there anything going on to simplify generics?
Yeah. So first of all, I'm going to dispute what you said. Generics are easy. All right, they're not easy. They're hard until they're easy. There's an aha moment with generics where once you get it, it becomes a lot easier. And I say this mostly just to encourage you to keep trying, right? A lot of people, they look at generics, they say, oh my God, this is so hard, I'm never going to understand it. Maybe they beat their head against it, a little bit. Don't get it and then give up. So I would encourage you, for example, like Venkat Subramaniam, who's a wonderful speaker, top-rated speaker at DevOps this year so far, has a great talk that he does on generics. He's been doing it at Java 1 the last couple of years. He does it at a lot of conferences. And so many people have commented, after seeing this talk, I finally get generics. It's not as hard as I thought it was. So if you can find that talk online, just look for, it's hard to spell his name, but just look for Venkat's talk. I think that will be helpful. But to answer the question, one of the most complicated things about generics is wildcards. And generics without wildcards are actually not so bad. They're also not so useful. To make generics useful, you need some mechanism for supporting variants. There's two options. There's declaration side variants, which is what C# and Scala picked. There's use site variants, which is what Java picked. Lots of people say one is better than the other. The reality is they're equally expressive. They each have different strengths and weaknesses. It turned out not to be practical to have picked declaration side variants in Java in 2004 without serious incompatibility problems with our collection classes. And that was one of the reasons why we ended up picking use site variants. There's recently been a couple of academic papers of mixing declaration side variants and use site variants. There's one called mixed site variants, which is a really kind of mind-blowing paper if you're into Greek symbols. We're not going to do that. That's super. That makes with the generics we have look so simple, right? But that's not what we're going to do. But there definitely are some things that we can do to borrow concepts from declaration side variants. For example, if you have a functional interface like consumer of T is naturally contravariant. It takes a T in, and it would be happy to take some subtype of T as well. So if somehow we could mark the interface consumer of T as saying, I am naturally contravariant in type parameter T, extends T. Then at the use site where you're supposed to say consumer of question extends T, the compiler could fill that in and say, well, you said consumer of T, but I know consumer is naturally contravariant in T, so I'll just pretend you said consumer of question extends T. There's actually been some usability studies done by academics about mistakes made by Java programmers with generics, and something like 60% of the mistakes that they observed were simply getting the variants wrong at the use site in a way that could have been inferred if there was a declaration side annotation that indicated the natural variance of the type.
We made those in streams, and Remy Thorax was a little reminder that we were getting it wrong. He was our declaration side variance human.
Yeah, experts make mistakes with it too. And during the review process, both Remy and Dan caught errors.
It's so easy to forget the question extends sometimes.
And your test will still work, right? So the simple cases will still work, and you'll forget about it. And so there definitely are some things that we can do to make it easier to move the burden from the user of an API to the provider of an API, which is which is consistent with our philosophy of put the work on the library developer so that all the library users don't have to redundantly do the work themselves.
I also think there hopefully will be improvements to the compiler going forward as well, so that certain errors don't bubble up and you get into this fight with your IDE, repeat test. Why isn't this working? I'm getting strange errors, and this type inference will improve, and there'll be less experience of this with lambdas and method chaining and so forth like that.
And better error messages help a lot as well. I mean, we've improved the error messages for generics in each of the last 4 versions of Java. And each time you improve the error messages, you reduce the time it takes for the user to say, oh, I understand what's going on. I know how to fix this. And there's a little bit of 2 steps forward, 1 step back, because we extended the range of type inference so much in 8, and that created new classes of error messages that we refined a bit in 8 that we'll refine more in 9.
Okay, question about arrays now. So when can I use a long value instead of an int to index an array? Or put another way, when can I create an array that's longer than that has more than 2 billion elements?
So this is a VM question, not a language question. Right, so we have arrays baked into the VM, and currently the restriction that the index is an int is part of what's baked into the VM definition. There's an initiative going on in Project Panama, which I talked about yesterday, both in the keynote and the sneak peek talk, to generalize arrays. And if you're interested in arrays, you should go watch the video that John Rose did at JVM Language Summit. I think it was in 2013, called Arrays 2.0. And it's a whole hour-long talk about, so you want to generalize arrays, let's look at what you're really asking for. And generalization of the index type is one of the many dimensions of generalization. There's also generalizations of how things are laid out in memory. Are they flat? Are they segmented? Are they sparse? Are they packed? If I want to have an array of things that are only 4 bits long, can I pack them in more tightly than a byte? If I know that my array is sparse, can I have a sparse representation, have it still look like an array? If I have something that is bigger than what fits in a contiguous segment in my heap, can I segment the array? These are all roughly the same question. And if you look at the combinatorial explosion of all of the different possibilities, you very quickly realize we're not going to add 2 to the n new array types to Java. So what we need is a mechanism to allow you to construct arrays with different characteristics. Long arrays, sparse arrays, immutable arrays, arrays whose elements are volatile, etc., from kind of a menu of ingredients, and then thereafter be able to index it like an ordinary array. And so that project is going on in Project Panama under the heading Arrays 2.0. If you're interested further, take a look at John's video. It's pretty cool.
I think it's in the Panama source code, isn't it? You can actually check it out today and have a look at it.
Yeah, David Chase has been doing some prototyping on that.
Yeah.
Okay, there's a question about checked exceptions. Are we going to do anything about checked exceptions?
We're going to keep throwing them.
I think that it was a little hard to understand the question, but I think there are a bunch of things lurking in there, so I'll interpret it. It's like, well, so everybody complains about checked exceptions. So are we going to do anything about that? And if so, what? And then there's also a specific one, which is checked exceptions in streams.
Mm-hmm. Sorry, let's take that as 2 separate questions, all right? So a lot of people are of the opinion that checked exceptions are a failed experiment.
Should we ask them?
Who here thinks checked exceptions were a failed experiment? Who thinks checked exceptions were not a failed experiment? Okay, that's actually more than I expected.
Yeah,
so
more
than half the room are not complaining loudly. So there's a segment of the room that's complaining loudly, when are you going to get rid of checked exceptions? And we've been hearing this chorus for many, many years. And it's really easy to assume that when you're complaining about something, and he's complaining about something, and she's complaining about something, that everyone agrees that this is a really bad thing, and why don't you guys get rid of it? But there's kind of a silent majority here of people who have either liked the idea or simply gotten used to the idea, or have just internalized how it works and they have billions of lines of code built on it, and they don't want you to come and break their code in the name of progress. So I think the problem is we're well aware of the pain that we have now with checked exceptions, but we're not quite so in touch with the pain that we would have in a world without checked exceptions. And so it's not as obvious an idea as it might look like when you say, who here hates checked exceptions, and you look at all the hands that go up. So this is the kind of decision that you kind of get to make once at the beginning of time, and you're kind of stuck with it. And I think we are stuck with it. That said, there are places where checked exceptions don't play nicely with some other features of the language. In particular, generics don't play very nicely with checked exceptions. It's easy for generics to abstract over data types. It's not so easy for generics to abstract over exception types. And I think that was one of those things that we thought we were handling well in 2004 that we then realized we didn't handle as well as we could have. And we did a similar thing with the Streams API where we looked at, well, what happens about lambdas that throw exceptions? And we considered, should we have a parallel set of functional interfaces, function with exception, supplier with exception? And we looked at the combinatorial explosion that we already had, where we had shapes, primitive specializations, and then also potentially adding exceptions and serialization, and we just couldn't take that 4x hit in expanding what was 40 some odd functional interfaces to 4 times that. So we did look at it. We also looked at a number of linguistic mechanisms for lightweight exception transparency, and we discovered they all had serious flaws where the cure was going to be worse than the disease. There is some interesting, research that's gone on into better mechanisms for exception transparency that we would still be interested in letting play out, but we don't think that there is an obvious solution on the table yet. But we do need to do something to make exceptions play nicer with APIs like streams, both in being able to just deal with checked exceptions, but also integrating exceptions into the model so that you can say something like, if an exception happens processing a given element, should you keep going, discard that element, should you stop and replace the value of the result? And that's something where I think we're ultimately going to want to evolve the API to deal better with error conditions.
So one thing I've noticed about checked exceptions is that, so I'm more of a libraries guy, so I don't deal with things at the language or JVM quite as much as Brian does. But if you look at the exception type hierarchy, it's kind of weird to begin with, but at least you can usually tell this is a checked exception and this is not a checked exception. But I also think that a lot of libraries have just gotten it wrong. They've declared a bunch of things checked exceptions that really should not have been.
Right.
And so I think I don't know if it's possible to evolve the exception library in a compatible way to deal with this, but I think if you were to revisit the idea of checked exceptions, I think fundamentally it's a sound idea, and there are some times when it is very, very useful for the compiler to tell you, you should handle this exception right here. And that's what checked exceptions are about. And the problem is that it was misused by a bunch of library writers, and so the compiler is constantly telling you to handle exceptions that you really cannot handle reasonably at all. And I think that's, from my point of view, that's where most of the pain is. And if there's a way that we maybe can evolve, and I don't know exactly how we would do this, but it would be nice to evolve the exception hierarchy somehow so that fewer things are checked, and only the ones that really need to be handled are checked exceptions.
Yeah, I think so. I think we made a lot of library design mistakes with exceptions in 1995 before we really knew what we were doing. And so there are plenty of examples. The poster child for what Stuart is talking about is, why does the close method on input stream throw an exception? What could you possibly do to recover from an exception closing the stream? You could try to close it again. Keep trying to close it until it behaves. So there are a lot of exceptions that are checked exceptions now in our libraries that there is no reasonable way to recover from. And I think that's the primary reason why people hate it so much, is that not that they have to deal with it, but they have to deal with it and there's no reasonable way to deal with it.
All right, so we only have a couple minutes left, and there have been a few questions on Twitter about what are the panelists' things like, what are the panelists' favorite features that they'd like to see, and what are the panelists, what are the biggest mistakes in Java, and what would they like to see changed? So anyway, so why don't we run through a few of those to close out the panel?
Everybody knows my most hated feature: serialization.
I would agree with that. It's just the time spent on that is just ridiculous.
My God.
I actually hate the security manager. That's my pet peeve.
Serialization is kind of the gift that keeps on giving. It's not only is it a complex feature that bites you in the backside over and over again, but every time you want to add another feature to the language, you have to look at its interaction with serialization, and there's almost always an oh my God moment when that happens. And I would say that during the development of Lambda, I don't know what the actual number is. It felt like a large number, but I would guess that 15 to 20% of the time of the expert group was spent dealing with serialization, which is just a total waste of time. But we couldn't not do it. We tried very hard not to do it. We tried so hard to ignore it, and but you can't ignore it responsibly. And then the result we got was not even something to be so super proud of. It was just a very tenuous, uneasy compromise of, well, it is the least horrible of the 37 horrible alternatives that we were able to come up with, so we picked that. But that's not really, what you want written on your tombstone, is it?
Okay, and then so I certainly have spent my share of time on serialization, but I think I should choose something different from these guys. Although serialization is up there for me too as well. But that is more of a pet peeve, I suppose. But it's the intersection of boxed primitives and the fact that every object has a monitor lock on it. And so what it enables people to do is do things like put a synchronized block using as its lock integer.valueOf1. And so it's like, well, what does that really do? Well, it creates a boxed integer 1, but in fact, there's also a rule in the specification that says that a certain range of integers will be identically equal to others. And so in fact, this code will work unless you change the value of the boxed integer. And so it won't work, for instance, if you say integer.value of 256. And it's like, this stuff. And so there's no good reason to write code like that, but you see it, and I don't know. I don't know if there's a way to change that, but so that's my pet peeve. Okay, so let's. We're sort of out of time, but quick rundown. What feature do you most want to see? Well, you talked about them all yesterday.
Yeah, I talked for an hour about this yesterday.
I want tuples and arrays of tuples nicely packed together so I can stream over them really efficiently.
Yeah, okay. All right, you stole mine. I was going to say tuples as well. But my use case for tuples is multiple, actually,
Sorry, I stole yours.
Multiple value returns, but no, multi-valued streams.
Yeah.
During the streams development, we had this thing, a by stream or a map stream, and did a whole wrestling match with that. But, there are times when you really want to have multiple values running through your stream, and the way to do that is with tuples.
Yeah.
All right, we're out of time. Thanks for all your questions. Enjoy the conference.
Thank you very much.
Step